Welcome to this lesson about errors in hypothesis testing. So in fact, does our conclusion always 100% correct? In fact, no. So our conclusions may be incorrect. So it is possible also to have incorrect conclusions at some time, at some level of possibility. So it is possible to have some kind of errors. So these errors are defined as type 1 error and type 2 errors. Before that, let's see the general hypothesis conclusion. We have the general formulation of hypothesis as we have seen. We have the null hypothesis, for example, mu equal mu naught. We have the alternative hypothesis, for example, mu does not equal to mu naught. So, eventually we are going to conclude one of the following conclusions. We are going to reject the null hypothesis, which means statistically the null hypothesis is false. Sometimes we are going to fail to reject the null hypothesis, which means statistically the null hypothesis is true. So these are our conclusions, but in fact it is possible that we committed some type of error in our conclusions. So now let's look for the type 1 error. So what is the type 1 error? Now suppose we have rejected the null hypothesis, but the null hypothesis was false. Now we are happy because in reality the null hypothesis is false and we have rejected the null hypothesis. So we are happy because we have done the correct conclusion. Our conclusion from statistics were exactly the same as reality. So it also happened that the null hypothesis to be true, but we reject the null hypothesis. So if we reject the null hypothesis when the null hypothesis is true, now we have committed subtype of type 1 error. And to calculate type 1 error, this is very simple. We have the probability to commit type 1 error is exactly alpha value. So why it is alpha value? Now suppose we have the normal distribution. In the first case, we have the two-sided test. In the middle here, we have the acceptance region, which is 1 minus alpha. Suppose we have two-sided test. So we have here the rejection area is alpha over 2 to the right and alpha over 2 to the left of the critical values. So now the values of this distribution lies from minus infinity to positive infinity. But when we have chosen the confidence level, in fact we have sacrificed by alpha percent or alpha of the value. So for example, if this area or the acceptance region is 95%, we have sacrificed by 5% of data, half to the right and half to the left. So now suppose some values here in the rejection area are really belongs to the same distribution, so we have committed type 1 error. So type 1 error is to reject the null hypothesis, so means to fall in the rejection area here or here. When the null hypothesis is true, which means the values here of z0 or here to z0 are really or in fact belongs to this distribution. So we have the probability to commit type 1 error equals to alpha. Now let's have this illustration table. We have the type 1 and type 2 error. Here in above we have the truth about the population. Here we have the decision based on our sample or our conclusion. So if our conclusion was to reject the null hypothesis and the null hypothesis in reality was false, so this is a correct decision. Now we are happy. But if we have rejected the null hypothesis and the null hypothesis was true, so we have made a mistake or we have committed some type of error. This is called type 1 error, and we have the probability of type 1 error is exactly alpha. So in the other hand, sometimes we fail to reject the null. If we fail to reject the null hypothesis and the null hypothesis was true, so we made the correct decision because the null hypothesis is true and we fail to reject the null. So this is a correct decision and we are happy. But the problem is when the null hypothesis is false. In reality, the null hypothesis is false and our conclusion was to fail to reject the null hypothesis. So we have type 2 error and the probability of type 2 error equals beta. Later we will see what is beta and what is type 2 error. So type 2 error in fact is failing to reject the null when the null is false. So it is important to fail to reject the null only when the null hypothesis is true in reality. So this is only an illustrating example. The type 1 error is called like false positive conclusion. Type 2 error is called like false negative conclusion. For example, this doctor says for this man you are pregnant, but this is impossible in fact. So he gave a false decision or false conclusion and he confirmed that he is pregnant, which is completely incorrect. For example, here this woman is pregnant in reality, but the conclusion was also mistaken. The doctor says you are not pregnant, so this is also called like false negative. False because the conclusion is false, and negative because this doctor claimed that she don't have pregnancy.